Welcome to the deep dive. We're always plunging into, well, the truly extraordinary. Think about that ancient dream, alchemy, turning everyday stuff into gold. What if someone was actually doing something like that? Finding significant amounts of gold, not in some remote mine, but from rocks you might just walk past. And using chemistry that's surprisingly, well, accessible. Today, that's exactly what we're unpacking. A fascinating, really unconventional, and sometimes kind of dramatic way to extract gold. And our source is really unique this time. It's an audio recording from the person actually doing it step by step. So our mission here is to get into the chemistry, look at the practical hurdles, and uncover the results, because they were genuinely surprising, transforming plain stone into pure gold. And the person who recorded this, they started with this rock, just an ordinary looking rock, they called it. They were thinking maybe 2 grams, maybe 5, something in that range. Had another sample too, where they said, look, even 1 gram would be okay. Let's just see what actually happened. So, okay, let's start with the rock itself, the raw material. Our guide described it as highly mineralized and specifically full of pyrite. Full of gold.
Right, but that pyrite and the fact that the rock was crumbly, those are actually good signs here.
Crumbly. How so?
Well, those physical properties, the crumbling, the pyrite, they're indicators of potential gold content. It suggests the rock's structure might have allowed gold to deposit, and it makes the first step, the preparation, surprisingly straightforward. The rock sort of helps you out.
Okay, so that weakness made crushing easier. Our guide apparently got it done pretty fast, maybe half an hour, crushed it down to a powder, ready for, the chemical part, dissolving it in a big canister.
That crushing is vital. You need maximum surface area for the chemicals to work effectively.
Right. So, rock powder ready. Now, the real sort of alchemy, I guess, the solvent, and this is where it gets interesting, not your standard lab stuff.
Yeah.
They created a kind of aqua regia, that powerful acid mixture that dissolves gold, but, and this is the twist, they use nitric acid and just plain kitchen salt.
Yeah, common table salt, not hydrochloric acid, which is typical for aqua regia.
Exactly. They specify the amounts, too. Almost a liter of nitric acid and just 3 tablespoons of food-grade salt. And it gets weirder. Instead of water, they added something called condensed solutions, described as, like, leftover aqua regia from dissolving old radio parts to boost the acidity.
Okay, let's unpack that because it's quite clever, actually. Combining nitric acid and sodium chloride, the salt, generates the necessary chlorine in situ, right there in the mix. That's what gives it the power of aqua regia, the ability to dissolve gold and other metals.
So the salt is kind of standing in for the hydrochloric acid.
Precisely. It makes the whole process much more accessible. You avoid handling fuming hydrochloric acid. This is what the creator calls their new method, and it seems central to their success.
And the condensed solutions, just trying to make it stronger.
It sounds like it. A bit unconventional, maybe recycling chemicals, but it suggests they're trying to optimize the reaction, maybe preload it with active chlorine species to get the dissolution going faster, especially if the ore is tough.
Okay, so they mixed this all up. How long did it take? About 2 days, apparently, for filtration, which they said was tricky because of the salt clogging things up.
Salt can definitely complicate filtration.
But after that, and 5 thorough washes, they ended up with this liquid, described as vibrant, bright yellow, clear, and very saturated.
That bright yellow color is a good sign, usually indicates dissolved metals, potentially including gold.
So how do you know for sure if gold's in there? You've got this yellow liquid.
Good question. They used a chemical test. Fresh stannous chloride.
Stannous chloride. Like a gold detector.
Pretty much. If dissolved gold is present, adding stannous chloride causes a reaction, usually forming a dark spot or precipitate. It's a classic qualitative test.
And did it work?
Oh, yeah. The guide said the reaction was amazing, a really strong active response. Dark color appeared quickly.
Wow. So gold confirmed.
Confirmed. Though they did note, the color intensity doesn't tell you how much gold is there, just that it is there.
Okay, so gold's definitely in the solution. Next step, get it out. Precipitation. And this is where things got, let's say, dramatic.
The precipitation step can be tricky. What did they use?
A chemical called pyrosulfite. Sodium metabosulfite, probably.
Okay, a common reducing agent for gold.
Well, common maybe, but the reaction was anything but calm. They described an immediate, intense, horrible smell. Said it cuts the eyes, made it impossible to breathe.
Oh, dear. That sounds like sulfur dioxide gas, SO2.
Is that dangerous?
Absolutely. It's a major irritant, pungent, chokes you up. That strong reaction really underscores the need for extreme caution. You must have proper ventilation like a fume hood or do it outdoors with wind direction in mind. Seriously.
Yeah, the creator actually had to leave the area entirely. Just couldn't stay near it.
I'm not surprised. But chemically, what the pearl sulfide does is it basically forces the dissolved gold ions back into solid metallic gold. It reduces them. The gold then falls out of the solution as a fine powder or sediment, and you don't need to, like, boil off all that acid, which is also hazardous.
So despite the awful fumes, it worked.
Sounds like it.
Yeah, the gold started turning dark brown and settled out overnight at the bottom. They also mentioned adding ice water after precipitating. Something about warm weather.
Ah, yes, that's a good practice. Gold can slightly redissolve, especially if the solution is still acidic and warm. Cooling it down quickly helps lock the precipitated gold in its solid form and minimizes any loss.
Interesting detail. But there was another snag. Mixed in with the brown gold sediment was this: white muck.
White muck. Likely some kind of byproduct from the pyrosulfite reacting with other things in the solution, or maybe excess precipitant. It means the gold isn't pure yet.
Exactly. So the journey wasn't quite over. That gold needed cleaning up.
Purification. Always a necessary step in these processes.
So what they did was filter out that initial mix, the brown gold powder and the white muck. Then they took that collective brown stuff and redissolved it. Another batch of aqua regia.
Starting the cleaning process.
This time, though, they used hydrochloric acid first, then added nitric acid. Roughly 1-to-1 ratio, they said. Dissolve the gold again, quite quickly.
Okay, a more standard aqua regia approach for the purification. And why is this step so important?
Well, the key thing they observed, the reason for doing this, was that the white muck didn't dissolve in this second acid bath.
Separation.
Exactly. The gold dissolved, the muck didn't. So they can filter the muck out, leaving a much cleaner, clean, concentrated golden solution, as they put it, gold chloride solution.
That's the goal. Isolate the gold chloride from the impurities introduced earlier. Smart. Gets you much closer to pure gold.
So now, second precipitation. Getting the clean gold out of this new solution.
Yep.
Used a different chemical this time.
Hydrazine.
Hydrazine, another strong reducing agent, often used for final high-purity precipitation of gold.
And the result?
Let me guess, much cleaner reaction.
Bingo. Instant gold precipitation, dark brown sediment again, and crucially, no bad smell this time. Yeah, hydrazine reactions are generally much less noxious than using sulfites like parasulfite, especially regarding SO2. It often yields a very pure gold precipitate too, so a much safer and cleaner final precipitation.
Sounds like it.
Yeah.
So now they had this dark, brown, presumably much purer gold sediment, ready for the final step.
The smelting, turning powder into a button.
Right, the grand finale.
Yeah.
They took that dark brown sediment, the precipitated gold particles, and smelted it down, high temperatures, melting it all together. And the result was a beautiful, solid piece of pure gold.
Fantastic. The payoff for all that work.
And the quantity, remember those initial guesses? 2 grams, maybe 5?
Yeah, what was the final tally?
The creator estimated the yield from this specific rock, this process.
Probably 25 grams of gold.
25 grams, wow.
Yeah. Truly surprising, right? Way, way more than they expected. A really substantial amount from one rock. That is substantial. Over 3/4 of an ounce from one ordinary rock. That's impressive. So what this really demonstrates, for you listening, is the potential effectiveness of this specific new method they developed, using the nitric acid and salt. The creator felt it was the best way to dissolve the material without the gold, sort of prematurely falling out of solution or causing issues later.
It really highlights how specific chemical knowledge, applied precisely, can unlock surprising value.
Absolutely. It's not just random chemistry, it's targeted application.
And our guide made another interesting point, these pyrite-rich stones. Apparently much easier to find locally than, say, hauling heavy ore down from distant mountains.
That makes sense. Accessibility is a huge factor.
Yeah, and they even hinted that future experiments might yield even better results. So they're clearly refining the process.
Always room for improvement.
So let's just recap. We've taken a pretty deep dive here. Started with a seemingly common rock full of pyrite. Then through some ingenious chemistry, nitric acid, kitchen salt, careful precipitation, dealing with some nasty fumes along the way.
Then refining, redissolving, precipitating again with a cleaner chemical.
They ended up with a significant chunk of pure gold. 25 grams.
It's quite the journey.
It really is. And it just shows you, doesn't it, the hidden potential that might be sitting in seemingly everyday materials. It shows that with the right know-how, and maybe a bit of daring, some pretty incredible transformations are possible. Makes you wonder, what other impossible transformations are just out there, waiting for someone to figure out the secret?